I'm David Hui, a team lead on the security platform team at Datadog, and today we'll be talking about security automation in the FedRAMP cloud. I've also got with me Phil here.
And I'm Phil Shea, an information security advisor here at Datadog. In today's talk, we'll talk about what Datadog's journey for FedRAMP has looked like up to now. We'll talk about the operational challenges we've encountered with meeting those FedRAMP control requirements. And we'll walk through a technical solution that we've developed here at Datadog and deployed to automate security monitoring. And we'll wrap up with how Datadog maximizes the value of that automation across security and compliance objectives. Let's start by talking about Datadog's FedRAMP journey. Datadog's entry into the FedRAMP market is driven by three primary objectives. First, support existing commercial customers who have been seeking FedRAMP authorization, some of whom had already sought approval to use Datadog, and others who were just entering the FedRAMP program. Second, to provide government agencies with FedRAMP authorized environments. In our case, we had a number of agencies who had already brought Datadog in using their own agency-specific processes. And third, to address demand for support at FedRAMP Moderate and beyond. We saw that FedRAMP, and especially the moderate impact level, was becoming a question with increasing frequency to our sales folks. And FedRAMP High, DoD support, export control data, and criminal justice are often recurring questions from our customers. So these drivers led Datadog to take a two-phased approach to FedRAMP. Our phase one approach to addressing FedRAMP was to take our existing commercial US environment, where, as I mentioned earlier, we already had some federal agencies as customers. FedRAMP tailored low-impact software as a service made sense as our sponsor, the General Services Administration, had already granted their internal authorization for Datadog's use. This is, of course, the lowest bar for entry into the FedRAMP program, and we were able to predominantly leverage the existing controls we had in place, with some tweaks and enhancements. But overall, we never lost focus that being able to support moderate workloads was where Datadog ultimately wanted to be positioned. And that leads directly into phase two, Datadog for Government, an entirely separate instance of Datadog. We built Datadog for Government in AWS GovCloud, largely as future-proofing. I mentioned earlier that FedRAMP High, DoD, export control, and criminal justice have been regular requests. Well, AWS GovCloud gives us the flexibility to be able to move forward from moderate without having to go back and change infrastructure down the road. For now, though, FedRAMP Moderate addresses the majority of the federal use cases presented. It's where approximately 80% of FedRAMP authorized systems exist now. So to get there, we took a hard look at the controls we were operating already and put in the time and effort to purposefully build Datadog for Government to the moderate requirements. Now, of course, it's a big lift to go from a tailored low-impact SaaS authorization to a FedRAMP Moderate standard, especially when trying to maintain Datadog's fast-moving operational model in a very quickly growing organization. One of the most pressing concerns for Datadog in tackling moderate was in security operations. It's one thing to design and implement the 325 moderate controls, but the day-to-day down in the weeds can be a drag on staff and resources. There are more than 25 controls in that baseline that require some level of almost near constant monitoring. And many of them are only tangentially connected to each other and draw from a diverse set of data from many varied system components. Things like access control, where monitoring for new accounts, changes to roles or permissions, and monitoring for the very open to interpretation atypical usage. Audit and accountability controls, taking all of the data from those components together and trying to make some sense of it for your organization. Configuration management, looking at what's changing, sometimes on a minute-by-minute basis. And system and information integrity controls with the catch-all system monitoring, malicious code, file integrity. Many overlapping pieces here, and more than one set of internal and external stakeholders to be able to provide data and response to. Couple all of that complexity with the number of sources that we're potentially drawing from for this data. AWS CloudTrail and other AWS service data, host, container level logs, SSH, applications, databases, internal services. Many of us in the SaaS world are using third parties as identity providers and to act as other third-party services. But that data also needs to be tied in to what's happening inside the boundary too. There's definite cross connections there. And we need that high scale tooling because all of this adds up to a fair amount of pressure on an organization. And of course, let's keep in mind that engineers want to have the freedom to build great products at the same time that we're asking them to keep all of this present in mind. So we need to find the place where we're getting the maximum possible value and supporting the most efficient operations. We need alerts that are timely and immediately actionable. They need to be significant or they'll end up just being noise. We need flexibility. The first answer is not going to be an exact right fit. And we know that we'll need to iterate and be able to grow over time as the system evolves. We need all those data sources to be consolidated in one place and tied together for correlation in one set of tooling. And we need the solution to be scalable, as we know growth is fairly constant. New use cases, new products, and more customers. So David, why don't you walk us through what we've done at Datadog?
So I'm now going to talk to you about our internal security automation system, Trident. Trident's a system we built in-house at Datadog for performing security monitoring on AWS. Trident enables developers to write security detections with the Go programming language. If you're not familiar with a detection is a snippet of code that identifies suspicious or malicious behavior in real time. These detections run on Trident on a cron-like schedule around the clock. Then you can alert through either email, PagerDuty, or Slack. These are very commonly used tools at Datadog, so it makes sense to also do our alerting through them. Trident's architecture is built in a very web app style. It features gRPC APIs. gRPC is a RPC framework built by Google that's in heavy use at Datadog. We use workers for asynchronous work. This is actually how the detections run. And then we have a scheduler that provides the cron-like functionality. Finally, we have CLIs and other tooling to facilitate development by some of our customer teams. Trident actually uses other off-the-shelf technology. We use the library Go plugin to be able to extend Trident with these custom detections. We use Postgres, and then we use AWS SQS and AWS S3 for queuing and object storage, respectively. Trident actually operates in kind of a unique style. At Datadog, we create many different data lakes that contain all security-related data. Specifically on our team, we actually focus on 3 different data lakes. We have an AWS Redshift, a Postgres, and an S3 data lake with files in the Parquet data format. Each one of these data lakes functions in a slightly different way and provides different features to the developer developing a detection. For Redshift, a detection can be written that functions at a high scale. For Postgres, a developer can use some of the complex types and database features. And then Parquet enables Spark support. So a developer can actually use Spark to perform very complex types of security monitoring. So we cover a variety of different data sources in FedRAMP. Some of the ones that Phil touched upon earlier, but also others. Some of the main data sources that we track are GoAudit, which provides Linux Audit D logs. This covers things like process events, AWS CloudTrail logs, This is where we get cloud provider audit data, Kubernetes audit logs, SSH logs, and other things as well. This data is ingested and processed using this tool called Mortar, which is a system we developed at Datadog. Mortar is a workflow manager for building EMR Spark data pipelines. We usually use Mortar for anything Spark related at Datadog. So now let's take a look at a detection that can run on the Trident platform. So this detection here uses two different types of data lake data. We have audit D logs, so this could be process events, and then we have IOC data. IOC data is what's called an indicator of compromise. So this can be IPs that are known to be malicious, domain names, things like that. So in this simple detection here, we take each process event and then we check if it contains a mention of any of these IOCs. If an IOC is present in that process event, then we'll alert. This example could catch shell commands such as the infamous curl to bash style of installing software. So if the curl command is made to a malicious IP, this detection might catch that scenario. And we'll actually go into this into a demo later on. Here's an example of a Slack notification from the Trident platform. In part A, you can see that this is a process event using the wget utility. In section B, you can see some reasons why this alert might be a false positive. And this is to alert a on-call analyst about certain reasons why this might be a false positive, why they might want to overlook this specific alert. And then C is a section that provides investigation tips so that an analyst can find more information about the server or the command. At Datadog, we actually use cloud agnostic tooling to do the majority of our work. Things like Kubernetes, Terraform, Bazel, and GitLab. With respect to Trident, this enabled us to deploy Trident and the rest of the security platform to a new environment very quickly. In fact, we were able to get Trident and all associated tools running on AWS GovCloud in a matter of weeks. And this actually applied not just to GovCloud, but all of the other cloud providers that we use at Datadog. And now we'll go into a demo. Today I'm going to walk you through the development of a Trident monitor. So this Trident monitor is going to detect instances of curl to bash commands. So here you can see what one of those looks like. Curl to bash is a commonly used installation method by some internet projects. It isn't recommended because you usually cannot visually inspect the script before installing it. Some malicious code or similar can be embedded within the script that you pull down from the internet. Instead, it's usually recommended to save the script, inspect it, and then run it locally. So on my local machine here, I actually have a web server running that outputs a set of bash commands. So this is kind of a simplified version of the installation scripts you would see on the internet. So if I curl port 8000, we actually see these two different bash commands. Additionally, I have a very simple ETL system here. So any command I run in my shell is actually saved to this Postgres database. So here you can see what's currently on this shell commands table. This table is important because Trident actually iterates through every row of a database table running a detection. So here is the actual detection code that runs within this Trident monitor. So here we have a function that takes in an array of database rows and filters it down to the ones that have an instance of curl to bash. Then down in this run function, we can actually see how Trident iterates through every row in a table. So Trident actually provides the different range IDs to use in the database query. They're used here with the parameters start and end. So in the code, we iterate through every single shell command. We filter it down to the ones that contain instances of curl to bash. And then we actually send out an alert. The alert is through PagerDuty. Since I'm actually on call right now, I'll actually receive that page. So now I'm going to demonstrate how we actually send that monitor to Trident. So since the Trident monitor is actually plain Go, we can compile it with the standard Go toolchain. After that, I'm going to send the binary over to Trident. Now I'm going to actually demonstrate the type of schedule that we're going to use with this monitor. So this schedule is in cron syntax, and it says that this monitor will run every 20 seconds. So I'm actually going to send this file over to Trident as well. So now we actually have a Trident monitor running, and it'll detect instances of curl to bash. So remember that web server I mentioned I had running locally? So if we pipe this to bash, that should actually work, and hopefully our Trident monitor will detect that instance. So as you can see here, bash executed those commands and it printed out those two statements. And here in Postgres, you can see that this command that we ran was recorded. So now we just await the PagerDuty notification. So that was my cell phone. So now if we check PagerDuty, hopefully we can actually see an incident around this. And there we go. Here we can see that one curl to bash command was detected. And we can actually see the command there. Curl localhost port 8000 to bash. And there you go. That demonstrates a little bit of what we can do with Trident.
Thanks, David, for that great view of the solution. So we've talked about the challenges we've run up against. We've seen how we've addressed those challenges. So let's talk about the outcomes, what this actually means for Datadog. It might be a bit cliche, but remains true today as ever. Security automation is most definitely a force multiplier. A single set of tooling where all our security relevant data passes through means we can be efficient, both in managing the data and the configuration of the tooling, and also with the output and actions derived from it. And it means we've reduced the role of the traditional eyes-on-glass security operations center in favor of a more nimble operational model, which frees up resources to allow us to continually build and provide a great service. What drives that is the output from Trident tooling is very high value. There's not much noise, and it's really the outlier when it does occur. That's because the monitors are tuned and can be updated to identify only those events of significance, the events and patterns that are truly cause for follow-up. And when those events occur, we're putting the alerts directly into the hands of the security response personnel and engineers that can drive resolution. And we're pointing them directly to the resources they need in terms of runbooks and playbooks. So we've standardized the response and built an organizational rhythm to responding to these events. And from the security and compliance perspective, it makes my job a lot easier when it comes to questions from sponsors and assessors during the FedRAMP process. We can show a full beginning to end set of documentation, plans, supporting resources, and response personnel, all packaged into a consistent methodology across this entire set of monitoring controls. We can demonstrate the tooling and supporting processes to both our agency sponsors and our third-party assessment organization, along with the alerts, artifacts, and long-term data storage. All in one set of tooling, no casting around for logs from different resources and trying to prove out how often and by whom they're being reviewed. And it's all backed by change-controlled code. There's nothing that makes it easier than showing the rules for the monitors, the schedules for when they run, and the alerts that they generate. Circling back to our earlier requirements, what we've presented here as our solution is a key capability for Datadog. We've consolidated all of our data sources and required monitoring into a single mechanism to evaluate all of our security relevant data. It's a very flexible solution that we can adjust as we need. We can add monitors, change or deprecate others, or adjust the timing or method or content of the alerting through our code repo. We've narrowed the alerts to provide maximum value, to be timely, and put playbooks into the hands of those response personnel for action. And as David mentioned, it can be deployed very quickly and function at scale to support growing operations. Datadog has used security automation to continually expand into serving the public sector, while also meeting our organizational needs. We hope this has been a useful topic for you. Thanks for joining our talk today.